813, we're going to start with the math notes box at the bottom of page 8, where we're going to be reading about step functions. All right, so let's see who we have to read. Dustin, could you read the first paragraph for us?
Starting with $1,000.
No, bottom of page 8 where it says step functions.
Step function is
There you go.
a special kind of piecewise function, a function composed of parts of two or more functions. A step function is a graph that is a series of line segments that often look like a set of steps. Step functions are used to model everyday situations where there are abrupt changes in the output of the function.
Awesome, thank you. Second paragraph, Isaac.
The endpoints of the segment on the step functions are either open circles, indicating the point is not part of the segment, or filled in circles, indicating the point is part of the segment.
Awesome, thank you. And the third paragraph, Noah. Mariana.
The graph at right models the situation where the tour bus company has buses that can hold up to 20 passengers in 5 minutes.
Awesome, great job, guys. All right, turn back one page to page 7. At the top of page 7, we're going to be looking at more applications for exponential functions, and we're going to be answering the question, how does it grow? So question 832 is saving for college. Suppose you have $1,000 to invest and know of 2 investment options that offer an 8% annual interest rate. You can invest in bonds, which pay 8% simple interest, or put your money in a credit union account, which pays 8% compound interest. Will the option you choose make a difference in the amount of money you can earn? Examine these 2 situations below. Okay, notice they've divided the page into 2 columns. So we've got simple interest on the left and compound interest on the right. In the first, in month 0 or year 0 is when you have $1,000. Both accounts. This account has 1,000. This account has 1,000. So right now they're equal, right? Okay. After 1 year, this account has $1,080, and this account has $1,080. So far, same, right? What happens year 2? They are no longer equal. So the simple interest is $1,160, and the compound interest is $1,166.40. Okay? After year 3, simple interest is $1,240, and the compound interest is $1,259.71. So far, we're all ready. Which one looks better? The compound interest has more money in it, right? And the goal is you want more money. You don't want to have less money, you want to have more money. Okay, so we need to figure out what's going to happen for year 4. So each year from 1,000 to 1,080, what was added? How much money? $80. And then from 1,080 to 1,160, how much was added? 80 again. Then from 1,160 to 1,240, how much was added? 80. You guys see it's just adding 80? So if you take 1,240 and you add 80, you're going to get 1,320. Okay? Over here, you're going to take $1,000. I'm going to show you how to do this on the calculator. You're going to start with your $1,000. There's a glare. There it goes. And you're going to multiply by 8%. How do you say 8% as a decimal? 0.08. 0.8 is how much? 80%. So make sure you say 0.08, not 0.8, because that's 80%. Okay? So 8% of $1,000 is $80. Did you end up with only $80 right here? No, you ended up with $1,080. So what do you have to do? You have to add it back to the $1,000, right? So you're going to take that previous answer and you're going to add the 1,000, and that's how you get 1,080. You guys want to see a shortcut? Okay. So instead of having to do those two steps, instead you can take the $1,000 and you can multiply it by 1.08. The 0.08 is the 8%. What does the 1 represent? The $1,000 that's already there. And when you hit equals, it gives you $1,080. Okay, so you can do it in one step by multiplying by 1.08. Okay, your calculator has this fancy function that it will also take the previous answer. So now, instead of retyping in 1,080, I can simply hit times and see where it says ANS. What does ANS stand for? The answer, the previous answer, and I'm going to multiply by 1.08 again, and I get $1,166.40. Okay. Then I want the previous answer in there again, so I simply hit times 1.08 again, and I get $1,259.71. Then I'm going to hit times 1.08, and I get $1,360.49. Okay, so each time, what am I multiplying by? 1.08. Okay, the 0.08 is the percent, and the 1 is the previous amount. Okay, so let's see how we can get our equations here. So for the left-hand side, it says part A, if you invest in bonds, your $1,000 would grow as shown in the table above. How does the amount of money grow with simple interest? It's going to add the same amount of money each year. So each year it's adding $80, $80, $80, $80. Okay? Part B says, by what percent would your balance have increased at the end of the fourth year? Show how you know. Okay? So you're going to take the fourth year's amount, which is $1,320, and you're going to divide it by the original amount, or the initial value. So the initial value was 1,000. So on your calculator, if you take 1,320 and divide it by 1,000, you get 1.32. What does the 1 mean? The starting amount, right? So the only thing you're really looking at is this 0.32, which 0.32 as a percent, now we're going the other direction, is 32%. Okay? Now let's look at the questions in the second column. Part C says, instead, if you invested your $1,000 in the credit union at 8% compound interest, that is compounded once a year, its value would grow as shown in the table above. How's it growing? Explain how compound interest is calculated. Why is there $1,166.40 in your account at the end of the second year? So the reason is because you're also earn money on your previous interest. Okay? So every year when you get interest, then the next time it calculates it on even the interest instead of just the original investment amount, okay, or the initial value. It's going to keep adding your money faster, right? Would you rather have $1,320, or would you rather have $1,360.49? You'd rather have this one, right? Okay. Part D, what will be the balance of the credit union account at the end of the fourth year? We already calculated that. By what percent would this account balance increase at 4 years? Show how you know. So we're going to do the same thing we did over here. We're going to take the fourth year's value, the $1,360.49, divide it by the initial value investment of $1,000. And that one's on your calculator will come out as roughly 1.36. The 1 is the initial investment, so we don't count that. But this 0.36 translates into 36%. So over here it was 32%. Over here it's 36%. Slightly better, not huge, but enough to make you want to do that account, right? So part E says which type of account, a bond with simple interest or a credit union account with compound interest, grows more quickly. Obviously the credit union account with the compound interest is going to be a lot better, right? You're going to have more money to spend on your college, okay? I'm going to move that up. Go ahead and turn over to the top of page 8. Top of page 8 is question 33 and 34. This time it says starting with $1,000, show on your graph how each type of investment, simple and compound, grows over 6 years at 5% interest. So now we're changing slightly, okay? So instead of 8%, we have 5%. How do you say 5% is a decimal? Good, not 5, not 0.5, right? 0.05. Make sure you put 0.05 in your calculator, otherwise it's going to go way too fast. All right, if you have two different colors to use, perhaps a pencil and a black or a blue pen, that would be helpful. If not, it's not a big deal, because we're going to graph the situations. All right, so here's what they want us to think about. What happens to the amount of money during the year? Assume that the interest is added at the beginning of a new year. What happens to the amount of money at the start of the next year? How is this shown in the graph? So we're going to look at that in just a second. But first, we're going to do the simple interest, where we're starting again with $1,000. And we want to find out what is 5% of $1,000. And you guys already told me it's 0.05, right? So you're going to take $1,000 and you're going to multiply by 0.05. And that tells you that it should be a 50% increase. So instead of just taking the 50 and adding it back to 1,000, what was the shortcut I taught you? So we're going to multiply 1,000 times 1.05, and that means the first, after 1 year, we have $1,050. Okay? Leave that number in there, simply hit times 1.05, and that means year 2, we should, oh, I wrote down the wrong number. Oh, no. Each year we're going to add $50. So, no, I was doing the wrong thing. Okay. 1,050, add 50, because we're not calculating off the previous year. So that's $1,100, then add 50 to get $1,150, then add 50 to get $1,200, then add 50 to get $1,250, then add 50 to get $1,300. Then for the second one, that's where you do the little trick. Sorry. Okay. So here's the trick. Now you're going to take 1,000, multiply it by 1.05, and you get $1,050. Leave that answer in there, and you multiply, bless you, times 1.05, and you get $1,102.50. Then you're going to multiply by 1.05, and you get $1,157.63. Bless you, I had to round it up because there's a 5 next to that too. Multiply that by 1.05. And that means at year 4, you have $1,215.51. and then do it 2 more times to get $1,276.28.